Okay, welcome everyone to the Hope Science Journey webinar. Uh, I hope everyone has had a good morning and good early afternoon today. My name is Moza Sharif. I'm the Science Initiatives Coordinator, and I would like to welcome you all to day one, session one of the Hope Science Journey. Today we have a variety of interesting introductory sessions. Displayed here on the screen are the 4 sessions that will be taking place today, which is the Emirates Mars Mission Overview, the Hope Science Analysis presentation, Mars Visualization Tools and Models, and Accessing EMM Science Data. So the timings of the session for today is from 4 to 6 p.m. And today we will be having the first run of the introductory session. The next introductory session, which will hold the same presentations for those who could not attend the full webinar today, or whoever is interested in sharing the link to register for the introductory sessions will be sent in the chat box. And again, we will also have another session of the webinar, which is known as the Science in Depth, next week on Sunday, November 8th. And all these sessions will be taking place through Zoom. And all these, the registration links will be shared through the chat box shortly. And if you do have any questions, please feel free to leave them in the question and answer, and we will do our best to respond to all your questions as well. And again, if you would want to know more about the latest updates and any upcoming events or initiatives, please feel free to stay connected with us in all these social media platforms. I'll leave it up on the screen here for about like 20 seconds. So if you want to go ahead and take a picture of that, please feel free to do so. So we will start off with the first presentation, which is the Emirates Mars Mission Overview by Maryam Al-Shamsi. So Maryam, please feel free to go ahead and share your screen.
Thank you, Moza. Just let me know when the screen is up.
Yes, you're good to go.
Assalamu alaikum and good afternoon, everyone. So I'm going to be presenting the Emirates Science Overview on behalf of the science team. As Moza mentioned, my name is Maryam Al-Shamsi. I am the EMM Instrument Science Lead and also part of the science team of the Emirates Mars Mission. So in 2014, His Highness Sheikh Mohammed bin Rashid announced the Emirates Mars Mission, and he also announced 4 program objectives that the mission needs to fulfill. So the first one is we needed to have orbit insertion coinciding with the UAE's 50th anniversary. So from that time till 2021, which is next year, it sets our development and capability building for the HOPE probe for 6 years duration, contributing and developing the science and technology sector. So we're moving from an oil-based economy to a knowledge-based economy, and developing UAE scientific capabilities. So also inspiring a new generation of students to go into the STEM fields and encouraging them to continue their studies in terms of science and space sciences, and also concerning with engineering. And then also the 4th program objective is for the mission to provide unique science data for the scientific community to use, and also encourage the UAE scientific community to focus more on space sciences research, and specifically also talking about Mars research. Now, why are we focusing on Mars? There is a lot of reasons why this mission is focusing on going and studying Mars. The first one is we're talking about billions of years ago. So scientists think that the Mars used to have similar environment as Earth, having life and also water and similar atmosphere to Mars. However, something triggered that, and we're trying to understand the constituents and trying to understand the different dynamic of the atmosphere so that we also understand Earth. Also, the mission provides us with opportunities to be able to develop our capabilities in terms of doing research related to Mars science, and also in terms of engineering as well. So as most of you know, we focus on Earth observation satellites. And this was the first mission that we're going to be focusing on space-related systems and beyond Earth. Now, a lot of missions already been to Mars. As you can see, we have rovers, landers, orbiters, flybys. A lot of missions are providing scientific data to understand Mars more. So how is our mission unique, and what is it going to be adding to these missions? It's also good to know that our mission is going to be complementing these sciences. And you can see here, this is the scientific value of EMM and how is it unique to the mission. You can see that comparing it to the different missions, if I can just get my pointer here. Comparing it to the different missions on the bottom, you can see that the Emirates Mars mission is the red mission, and on the left, on the right, sorry, you can see that EMM is going to be providing different times of day science data sets that will be helping us to assess the atmospheric circulation and transport of Mars. And this will be capturing also not just all times of day, we were also going to be capturing it in all times and all the 4 seasons on Mars. Now, who are we as a mission? As you can see here, we have Mohammed bin Rashid Space Center. We are the project management of the mission. We also have the UAE Space Agency funding the mission, and they are also part of the team. We have the science team, which encompasses Mohammed bin Rashid Space Center, Arizona State University, LASP, Space Sciences, LMD, and SSL UC Berkeley. We'll also have researchers and experts from all around the world who are also part of the science team. This is better. So in terms of the spacecraft and mission operation, observatory, and spacecraft INT, it's a collaboration between Mohammed bin Rashid Space Center and LASP. Instrumentation-wise, I'm going to be talking it more in a bit, but it's also a collaboration between Mohammed bin Rashid Space Center, LASP, ASU, and SSL UC Berkeley. Talking about navigation lead, it's provided by Kinetics Aerospace. And when we're talking about the launch vehicle, it was provided by Mitsubishi Heavy Industry, MHI. Now, the mission is based on knowledge and technological partnerships between us and our academic partners. As you can see, this is a result from the different milestones and meetings that we have during the 6 years. It was a collaboration effort between UAE and our international partners. Now, when it comes to the science questions and why are we studying Mars, the first question, it's focusing on the lower atmosphere of Mars and studying different constituents on the lower atmosphere and how it's being affected globally, diurnally, and in all seasons. I'll jump to the third question. The third question focuses on the exosphere and how hydrogen and oxygen are escaping the planet. And then we're also focusing on the second question, which is connecting the lower atmosphere to the exosphere by studying the thermosphere and correlating the effects from the lower atmosphere to understanding the escape rate of the different constituents. Now, as you can see here, as I mentioned, we have the different constituents. I'm going to focus first on the top right. When we're talking about the lower atmosphere, we're going to be measuring observation from 0 to 50 kilometers. We're going to be measuring dust and water vapor thermally using their infrared spectrometer called Emirates Mars Infrared Spectrometer. Also in the lower atmosphere, we're going to be studying water ice clouds and also the ozone, which is a good tracer of water. So we're going to be capturing this using the UV band. And also we're going to be providing high resolution images of Mars planet. And this is going to be done using our Emirates Exploration Imager. And then we're focusing on the upper atmosphere and the thermosphere of Mars. So we're going to be studying carbon monoxide and the escape of hydrogen, oxygen from outer the planet. This is done using our far ultraviolet spectrometer, EMUS. Now the science flow, and as you can see, as I mentioned, from the three science questions, it flows down into four key investigations that we would like, that is going to be conducted using EMM. So we have the first one, which is focusing on the thermal state of the lower atmosphere. The second investigation focuses on the lower atmosphere and studying the key constituents. And then the third question, which focuses on the thermosphere and capturing neutral species. And then we also are going to be doing a three-dimensional structure of the exospheric species, hydrogen, oxygen. These are going to be captured using our three instruments, and I'm going to be focusing on the different investigations and how it's going to be captured. So the first two, as I mentioned, are the lower atmosphere. The first one is going to be captured using emirs, and the second investigation will be a partial observation between emirs and EXI. So first I'm going to be focusing on emirs. So EMIRS, our infrared spectrometer, is a collaboration work between Arizona State University and Mohammed Barrash Space Center. It has a scanning mirror, as you can see here, that's going to be capturing the atmospheric constituents of Mars. And we're going to be providing 60 images per week, around 20 per orbit, which I'm going to be mentioning in our next slides. With the spatial resolution of better than 300 kilometers and spectral range between 6 to 40 micrometers. So what is EMIRS going to be capturing? EMIRS is going to be capturing dust, optical depth, water ice, optical depth, water vapor column abundance, also temperature profile of the lower atmosphere, which is 0 to 50 kilometers, and capturing also the surface temperature in order to understand the thermal state of the atmosphere. Now, as you can see on your left side, this is the CAD model of the instrument, EMIRS, and this is the flight structure that was already been set in HOPE probe. And you can see, as I mentioned, the scan mirror, so it goes around in that direction to capture its observation. And this is how EMIRS observation is going to look like. So it's going to be capturing different data sets along or across the Mars surface. And as you can see, at the same time, while it's slewing and rotating its scan mirror, the spacecraft is at the same time going to be slewing that way. So this allows us to capture the whole surface of Mars efficiently. Now, the second investigation, as I mentioned, is a partial investigation by EMIRS and also EXI. So now I'm going to be talking about EXI, which is the Emirates Exploration Imager. It is a multi-band imager that provides us with high resolution imagery, around 12 megapixel images. It has 6 bands and a filter wheel mechanism, and its resolution is better than 10 kilometers. So what is it going to be measuring? It's going to be measuring water ice clouds along with EMIRS water ice cloud observation. It's also going to be measuring ozone at the 260 nanometer. And also it's going to be providing colored images in the RGB. So this is how EXI is going to be capturing its observation. It will first capture its observation. It needs a nadir, so it doesn't, it requires the spacecraft to be stable in order to take its first observation. We have then EMIRS observation. As I mentioned, EMIRS needs the spacecraft to slew while it's taking its observation. And then we're going to be taking a second observation for EXI in order to complete the data set in case we do have missing data from the first observation. So on the left, you can see this is the CAD model of EXI. As I mentioned, EXI has UV band and also visible bands. So it has a UV channel and also a visible channel, and it also has a filter wheel with the different bands for the science observation. This is the real flight structure that was already set on the spacecraft. Now focusing on the third investigation, which focuses on the thermosphere, and also focusing on the fourth, which is focusing on the exosphere. These two are both captured using our EMUSE instrument. EMUSE is a far ultraviolet spectrometer. It's going to be capturing the escape of hydrogen and oxygen from the planet. These are the building blocks of water, and also measuring the thermosphere. So capturing oxygen, carbon monoxide. So when we're talking about thermosphere, we're talking about 100 to 200 kilometer altitude, and then exosphere is beyond 200 kilometer altitude. EMU's wavelength is around 100 to 170 nanometer with spatial resolution of better than 300 kilometer on disk. And it has two spectral resolution. We have the 1.3 nanometer and the 1.8 spectral resolution. Now, when we're talking about what EMUSE is going to be capturing, we have the scientific targets that are focusing first on the thermosphere. If you would like to see this picture, it's focused on thermosphere, which is from, we're going to be capturing the oxygen at 130.4 and 135.6, and also carbon monoxide from 140 to 170 nanometer. This is using the spectral resolution of 1.3 nanometer. And then we're talking about the exosphere, measuring basically the hydrogen and oxygen corona. We're going to be measuring the Lyman alpha and Lyman beta, and also dim and bright oxygen in these altitudes. And this is going to be done using our 1.8 nanometer spectral resolution. So this is EMUSE. It's a collaboration between Mohammed Barash Space Center and LASP. Detector also is the development by LASP, by SSL entity, UC Berkeley. And this is a cut through, if I should say that, the cut through of EMUSE. As you can see, this is where the light is going to come in. Maybe I need to show you this first. This is where the light is going to come in. And then we have these baffles here, telescope baffle, and then we take the scientific observation, and this is where the detector is. Now, when it comes to the spacecraft, this is HOPE. It has a mass of 1.3 tons and uses an X-band communication stream. And then also when it comes to the power requirements, it's 477 watts and uses a propulsion system of monopropellant hydrazine system. The propellant system by itself is around 800 kilograms. So HOPE probe was successfully launched on the 20th of July this year at 1:58 a.m. UAE time. It was a successful launch. This is a picture of the launch day. It was successfully launched by Mitsubishi Heavy Industry H2A launch vehicle from Tanegashima Space Center in Japan. As I mentioned, we had a successful launch, and this is the journey that HOPE is going to be taking. HOPE is currently cruising to Mars, and it's going to be it usually takes around 7 months to reach Mars orbit insertion. So we have a couple of months before HOPE reaches Mars in February 2021. When it comes to the science orbit of the mission, our orbit is unique. It's around 20,000 by 43,000 kilometers. So it will provide us the needed accuracy to capture the constituents that is needed in the lower atmosphere and the dynamics of the atmosphere of Mars. At the same time, it allows us to capture the corona and the escaping of hydrogen, oxygen to space. So when it comes to the orbit period, it will be around a 55-hour orbit period. Now, as I mentioned, the launch was July 2020. We had a successful launch and operation, early operation phase. This is the phase where all the instruments and the subsystems of the spacecraft is being checked out successfully, just to make sure everything is going fine. And we have officially entered the cruise phase. So the spacecraft is currently in the cruising to Mars. And then we will be having a Mars orbit insertion in February 2021. Capture orbit will be around 500 kilometer by 44,000 kilometer, around 35-hour orbit. And then we are going to be transitioning into the science orbit. And this will be with a series of trajectory correction maneuvers in order to go into that orbit. We're going to be staying in the science phase for around 2 Earth years in order to capture which is equivalent to 1 Mars year, to capture all the seasons on Mars. We're expected to have an extended mission, 2 more years, and then expecting to have a decommissioning at 2025. Communication is done through NASA DSN. We have a low gain antenna and a high gain antenna to get the data rate needed for control and communication and data download. In terms of the mission control, we have the main mission control operations center in Mohammed Barash Space Center. We also have a mission facility in LASP, just to make sure we cover all the timings for contact if we needed different timings to contact the spacecraft. We have also instrument team facilities contacting the mission operation for data and pipeline related for processing the scientific data. And then we have the Science Data Center, which is going to be taking all the scientific data and sharing it to the science community, which is going to be the Emirates Science Data Center. And this is where all the researchers and scientists are going to be getting their data, and it will be available for everyone to use. So these are all my slides. If you have any question, I will be happy to answer in the Q&A box. Thank you.
Thank you very much, Miriam. We have a few questions submitted in the Q&A box for you. There's one question from Krish, which is, what's the main motive of this mission?
So the mission is bigger than just sending a spacecraft to Mars and study the atmosphere of Mars. It's more of also developing our capabilities in the UAE to encourage the science community to study and go into the STEM fields. It's encouraging them to do research in terms of Mars science. It's about also developing our capabilities in terms of space sciences, in terms of engineering, development, space related systems. So it's more than that. It's also focusing, if we're talking about economy wise, it's focusing on creating more institutes which are focusing on doing space and science related research. It's also providing opportunities for students to go into the fields. It's a bigger mission than just sending a spacecraft to Mars. We are also going to be sharing the data with the international science community in order to find new discoveries also in terms of Mars science.
Thank you, Miriam. And here's an additional question from Amar Tayyib. What's the expected lifetime of the HOPE probe?
So HOPE probe, as I mentioned, we are going to be having the science phase of the mission for 2 years. We are also expecting it to have a 2 more year lifetime. So we're expecting to have extended mission to do other science, maybe more interesting science also from the community's needs. And we're expecting decommissioning of the spacecraft to be in 2025.
Thank you. One last follow-up question. how long would it need to operate to be considered to have completed its intended data collection scope?
So when it comes to gathering the data sets, we are going to be capturing as much as we can. So as long as the mission is alive and we are capturing data from our instrumentation, we are considering that we are capturing the data in order to answer our science questions.
Thank you, Mariam. Now we can move on to the next presentation by Hassa Al-Matroshi, which is the Hope Science Analysis presentation.
Thank you, Moza. Let me share my screens first. Is it on? Yes. Thank you, Mariam. Good afternoon and good evening, everyone. So this is Hassa Al-Matroshi. I'm the MEMM Science Deputy Project Manager of the mission, and I'm going to present to you today Hope the Science Analyses. So Mariam has presented just now the process that we've done when it comes to the mission design. So we start with the EMM scientific questions and then flow down to the objectives, investigations, and then the data products that comes from the instrumentations. But in this presentation, we're going to focus on the path that we would like to set up from the data products. So after we begin the science phase, how we're going to use the scientific data products to answer our scientific objectives. So this process is called science closure, basically. And in this process, we identified for each objective the kind of scientific analysis that we need to do. And then under each scientific analysis, we would like to highlight the data products that we will use from the mission or even outside the scope of the mission, and what kind of scientific models we need to have in order to achieve the science analysis. And by drawing this kind of roadmap, we have a clear path. Once the data products are received from the HOPE mission, we're able to facilitate the understanding of the Martian atmosphere using the data that we have to achieve the whole collection and objective of the mission itself. So Mariam had showed us that the Emirates Mars mission has 3 scientific questions, which are related one-to-one to 3 scientific objectives that we have. The first objective focuses on the lower atmosphere of Mars. The third one focuses on the exosphere of Mars, which is part of the upper atmosphere. And then objective B correlate both of them together, which is very important to understand the dynamics of the Martian atmosphere. In here, I have in the right a panel of each instrument and the data products that we will have from each one of them. I'm going to keep this panel on for all the slides that I have so I can highlight the data products that we will use for each scientific analysis that we have. There is another thing that I'm going to highlight during my presentation, which is an important visualization tool that the science analysis team will be adopting into their activities, which is JMARS visualization tool. And then the other one, which is LMD, Mars Global Climate Model, and this will help us simulate the Martian atmosphere based on the understandings that we have currently about it from the simulations and physical model, in addition to the observations from other spacecraft as well. So we can start at first by objective A, which is characterizing the Martian lower atmosphere. So we do have 2 scientific instruments looking into the Martian lower atmosphere. We have EXI and then we have EMERS. And that's why EMUS, as you can see on the right, is highlighted out because it focuses on the upper atmosphere. We do have 4 analyses, part of the objective A. So if we achieve them, then we can say that objective A is achieved. The first one is about merging EMERS and EXI observation into a combined multi-dimensional snapshots of the global atmosphere. And we're planning to do this kind of combinations and merging every 10 days because this is when we expect the whole probe to get a whole information about all local time in the Martian atmosphere for the whole planet. So EMERS data, the whole constituents that we'll get from EMERS in addition to EXIs will be merged using GMARS visualization tool, as I mentioned before. And then by looking into the snapshot of the atmosphere, we're going to move 10 days by 10 days to see what kind of changes are happening, to capture the sub-seasonal changes in addition to the seasonal, and then to have a global perspective of the Martian atmosphere. So this will help us understand the behavior and the processes that goes into the dynamics and the climates of the Mars. The second analysis that we have is comparing products of similar data quantities between EXI and EMERS, and that is water ice. So you can notice from the highlights in the right that the water ice will be captured by both EXI and EMERS, but both will capture them within different wavelengths. So we're looking at the same quantity, but from two different perspectives. So combining them, both of them together, will give us more information and characterization for water ice in the Martian atmosphere. And that is important because water ice plays a big role when it comes to the Martian general circulation and in specific the water cycle in the Martian atmosphere and Mars as a planet. The third analysis that we have is about conducting spatial and temporal comparison to the LMD-GCM, which is the model that we're using, in addition to other observation from spacecrafts and data sets. So it's very important, and you're gonna see this in every objective. We'll take the data products that we have, and then we will compare them to our current understanding of the Martian atmosphere. And our current understanding stems from two things. One, from the scientific models, and in this case, we're planning to use LMD-MGCM, and our own developed models of forward radius of transfer model to understand the Martian atmosphere. And then we're going to tap into other spacecrafts. So there are other spacecrafts around Mars capturing information about it. So we're going, when applicable, compare similar quantities between HOPE scientific data products and those missions in order to verify the information and then put them in comparison together to understand the Martian atmosphere better. The first science analysis that we have is about data assimilation techniques. Basically, data assimilation is taking all the observed data from the HOPE probe and then combining it with data or theoretical data from the models. And in this case, it's LMD-GCM. Combining them both together will give us maps without gaps. And this is very helpful into understanding the circulation of the constituent in the atmosphere of Mars. And we'll be using EXI and EMERS data as a whole into this data assimilation techniques, giving more priority to EMERS data products. The second objective that we have is related to correlating the lower atmosphere of Mars and specific to the escape rates in the exosphere of Mars. And we do have in here 3 science analyses outlined. The first one is correlating conditions in the lower atmosphere with that in the upper atmosphere. And GMARS would be helpful in that, and the models will actually be helpful. And you can notice that we will need every bit of information that we will get from the HOPE probe. So we're using all data from all 3 instruments to achieve this kind of analysis. The correlation between the lower atmosphere and the upper atmosphere can be done in different ways. Simply, it can be done by empirical correlation. So basically, we get the data set, we see what does it tell us about the lower atmosphere, and if we saw changes, we go to the upper atmospheric data, we see if similar changes happen, and then do a correlation. And this will only give us a causal effect between the physical quantities, but to understand it even more, we would need to go back to the models and our current understanding and studying the covariation between them to verify what is the dynamics and what is the connection between both of them together. The second analysis that we have is about comparing the escape rate variations, which is in the upper atmosphere, with the thermospheric conditions. So we do have the thermosphere layer, which Mariam had mentioned before. This is a very important layer. The thermosphere is the lower boundary of the upper atmosphere, and it's very reactive to the lower atmosphere dynamics and the upper atmosphere conditions as well. So it's a very good layer in order to understand the correlation between the two. So we would be comparing the thermospheric conditions to the escape rate that we will be having from the exosphere itself. So this will help us to determine the link between the thermosphere and the hydrogen and oxygen escape rates. And it will help us even quantify the likelihood that when there is a change in the thermospheric physical parameter, how that impact the oxygen or the hydrogen and the exosphere itself. So we're relying in this analysis only on EMUS data, because this is what we need, as the EMUS will be capturing the upper atmosphere dynamics on its own. The third analysis is analyzing the response of the atmosphere to episodic events. So episodic events are those natural phenomena and events that are happening in the Martian atmosphere that we know about from different missions that have been there. And we know even from different analyses or studies that have been done using previous data and models that these events do have an impact either on the upper atmosphere or the dynamics as a whole. So we, as part of the Immerse Mars Mission Science team, will keep an eye on it, and we'll be monitoring these events. So whenever they happen, we're going to utilize the time and the data to explore them even further to understand how they impact the Martian atmosphere and in specific the escape rates. So in the list that we have in here, when it comes to episodic events, we are going to start first with dust storms. As you know, the Martian planet has one of the biggest global dust storms in the solar system as a whole. So we know from previous studies that dust storms do impact escape rates. There have been analyses quantifying how the hydrogen escape is increasing when the global dust storms were noticed in the planet itself. So this would be monitored, and we will be using EMERS data. We would need to use the dust optical depth that we will get from EMERS and the atmospheric and surface temperature to understand the dust storm itself, and then the derived escape rates from the EMUS instrument as well to do the correlation and to understand it even more. The second event that we're going to target into studying is solar flare effects on escape rates. What we mean by solar flare, this is basically a solar activity event. So solar flares can be defined as impulsive, sudden releases of extreme ultraviolet X-ray radiation from localized regions in the solar disk. And studies have shown that this does impact, especially the thermosphere of Mars. So we'd like to understand this even better. And I need to highlight in here that using the instruments that we have in HOPE-PROB, we will not be able to get information on the solar flare, but what we will be able to do is observe the response that the atmosphere has when solar flares exist. So we will rely on other data, other instruments, or even Earth observation instruments to give us information about the solar flares in specific. Same goes when it goes to the third event, which is the solar energetic particles, SEP, and coronal mass ejection, CME, effects on escape rates. Those as well are related to the solar activities. Basically, CME is a large-scale eruption in the solar disk. It propels hot plasma into space, and the SEP is a high-energy charged particles. They are accelerated either by solar flares or by interplanetary shock. So those travel and impact the Martian atmosphere as well from the sun until there. And we would like to understand how they impact the Martian atmosphere, and we will be observing that using the thermosphere and the escape rates as well. The fourth event is polar cap variability. So when we look at the polar cap, as you can see from the images I have in here, you can see the variation in polar cap. Basically, the polar cap grows in the fall and winter, and then it sublimates in the spring and summer. And water cap consists of water, ice, and CO2 mainly. So we would like to monitor this kind of variation and whether they have an impact on the Martian atmosphere as a whole, specifically the upper atmosphere as well. The last one that we have in here highlighted is the dust deposition and removal events influencing surface temperature and albedo. So we will keep an eye on these kind of events. We know dust have a lot of impacts on the Martian climate as it has in here on Earth. So whenever such events happen, we'll keep an eye on it and we'll see what kind of correlation we can draw back from the data that we have. And dust information we will be getting from EMERS, and EXI will help into getting us information of these dust events from the visible images it offers. With that, we conclude objective B analyses that we have, and we can move to objective C. Objective C is more focused on the exosphere of Mars. Exosphere of Mars is the outermost layer of the upper atmosphere. And in this layer, where hydrogen and oxygen escapes Mars. So it's a very important layer, because if we're talking about Martian atmospheric loss, this is the layer to monitor. This is the layer where we should quantify the escape rates, and why do we have a thin atmosphere right now compared to the thick atmosphere that Mars had 4 billion years ago. So to achieve this kind of characterization, we do have 3 analyses. And all these analyses will be achieved by the EMUS instrument, because this is the instrument that will look into the upper atmosphere of Mars. Thus, EXI and EMERS are highlighted out from this presentation. So the first one is comparing EMUS-derived density structures to model predictions. So we will get densities of EMUS-derived through our scientific data products. And what we will do is compare them to our models. So we already have scientific models developed, thermospheric hydrogen and oxygen prediction models, using our understanding of the Martian atmosphere, and we will compare them with the actual derived densities from the instrument itself. This is very important because based on previous studies and previous developed models, we understand that the hydrogen and oxygen densities, they are much impacted by seasons and by spatial variation. On the right, you can see a diagram just showing how this kind of information will be captured by the whole probe. So the corona, or the densities, will be captured twice per orbit. We have 2 instances where we're looking downward into the planet, where we'll be identifying the densities of hydrogen and oxygen. And then we have 2 other instances perpendicular to the other observations that we're looking outward of the planet. And this is because hydrogen is everywhere when it comes to space, and we want to subtract the background hydrogen from the hydrogen that exists in the Martian atmosphere as a whole. So taking this kind of observation into consideration and comparing it to the models that we have, especially the LMD ones as well, would be able to have a numerical quantifications and to understand the variations that we see in the densities, and provide even a more in-depth knowledge of why these variations exist based on the processes that happens. The second analysis that we have is deriving the hydrogen and oxygen escape rate. So the data products that we have goes up to densities, but within the science closure of objective C, we will be deriving the escape rates of hydrogen and oxygen. Hydrogen and oxygen specific because those are the most prominent escapes that happens in the Martian atmosphere, and because they are the building blocks of water. So if you want to understand the water cycle and why water does not exist currently in its liquid form in the Martian atmosphere, we need to understand those 2 together. So when we look at the escape of hydrogen mostly escape through gene escape mechanism. So that happens when the hydrogen atoms gain an energy through collisions. This might lead to an energy increase beyond the speed of the loss, and then it can go and escape the Martian atmosphere as a result of that. Oxygen, on the other hand, it depends on photochemical escape, which is mostly related of gaining energy from the sun. So both escape rates, we have already developed models to derive them. We do have 3D oxygen photochemical escape model and 3D hydrogen gas escape model developed by the team itself to derive these quantities. The last would be to take the derived escape rates from hydrogen and oxygen and compare them to model prediction. This is again to verify our information, to gain new insight when it comes to the comparison, because whenever there is a gap between the 2, that means that there is something that we don't understand about the Martian atmosphere that we can capitalize and use the data to understand more. So that's what we have. And NMD would be a model would help a lot in that, as well as the 1D photochemical model that will help us understand the Martian atmosphere as a whole. With that, we conclude the analyses defined by the Emirates Mars Mission Science team to achieve both objective A, B, and even C. But all these analyses will be done when the data will be received. So when the science phase will begin, and this would be by May 2021. So the science team, up to from the beginning of the mission until now, they haven't been ideal all this time. So we've been preparing all the scientific data pipeline algorithms that we need. We've been preparing the models that we need to put in place in order to achieve these kind of analyses. And we've been even utilizing other spacecraft data that are similar to the data that we will have from our mission, EXI, EMERS, and MUSE, in order to do scientific analyses ahead of time to understand what we should expect when the data would come. So this is an opportunity for everyone who is interested to study the data or to utilize the data when they come during the science phase. You can start from now and utilize other spacecraft data that we believe are kind of similar to the data projects that we will have. They might have different kind of coverage than the whole probe that we'll have, but at least it will give hands-on experience when it comes to analyzing the data, and that will prep each researcher or scientist to come and analyze the data when it comes from the whole probe. Feel free to capture this slide if you're interested. And with that, I'm going to conclude my presentation, and I would be open to any question you have.
Thank you very much, Hassa. Just one question that I believe would be quite beneficial to address here for the attendees. How did you come up with the mission science objectives?
That's a really good question. The scientific objectives of the mission were derived based on the community need. So when the mission was set forward, there was a programmatic level requirement from the government itself that the mission has to provide unique knowledge and unique science that hasn't been done before. But at the same time, it has to complement the analyses and the results that have been available. So we've looked into two things. One, we've done meetings with scientists in the field to ask about the gaps that are currently existing within the knowledge that we have and within the literature, and what they would hope to see when it comes to analyzing the Martian atmosphere. The second thing that we've done is we went into MEPAG. This is a Mars community that highlights the priorities of studying the Martian atmosphere. And what kind of investigations that are needed, and what kind of priorities it has when it comes to studying for different kind of objectives for atmosphere, geology, or even colonization and so on. So we've developed objectives to make sure that, one, they feed the community need, and then second, it aligns with the priorities for the Martian atmosphere community.
Thank you, Hassa. And one more question to be added here by Ali. He asks, the Martian atmosphere forms a conductive obstacle to the solar wind. Will EMM focus to study the ionosphere?
Okay, so that's a good question, honestly. The Hope will focus on studying the thermosphere and the exosphere of Mars. The ionosphere falls somewhere in between them. So however, we do not have instrumentations that specifically detect the ions, but we're more into studying the atomic hydrogen, atomic oxygens in there, in addition to the carbon monoxide when it comes to the thermosphere as well.
Thank you very much, Hassa. Now we will move on to the next presentation, which is the Mars Visualization Tools and Models by Maryam Youssef.
Thank you, Moza. Can you see the slides?
Yes.
Hi, everyone. My name is Maryam Youssef. I'm a science data analyst in the Emirates Mars mission. And today we'll be talking about Mars visualization tools and models, which Hassa mentioned earlier in her presentation. So What are visualization tools and models? They basically refer to the techniques used to communicate insights from data through visualization representations such as maps, charts, and graphs. So after the data is collected, processed, and modeled, the relationships need to be visualized so we can make a conclusion. And data visualization tools are essential for analyzing a massive amount of information and making data-driven decisions. So those tools can be available online or downloadable as softwares, and they could have similar input parameters such as longitude, latitude, local time, orbit, season, and so on. So today we'll be talking about LMD-MCD and GMARS. LMD-MCD or LMD Mars Climate Database is developed by Laboratory de Meteorologie Dynamique in France with several partners. They provide scientists and engineers and everyone with realistic and reliable modelization for the Martian climatological system. And the other tool is called Java Mission Planning Analysis for Remote Sensing, which is developed by Arizona State University, which also provides us with mission planning and data analysis tools for NASA's orbiters. And it's available for everyone to use. So what are the similarities and differences between those two models? The similarities will be that they're both graphical user interface. They're both free of charge. They provide data of the lower atmosphere of Mars, and they can be downloaded. The differences could be that LMD-MCD has real data of past missions and modeled using theoretical methods, and GMARS only uses real data of past missions. LMD-MCD provides data for all the layers of the atmosphere, and GMARS provides it only for the lower atmosphere. LMD is available online and can be installed. GMARS requires installation and has an open source. LMD provides us with Martian data only. However, GMARS provides us with Martian data, planetary, and other natural satellites data. And LMD displays the data on a map format, and GMARS maps the data on surface geology of the celestial body selected. So how is EMM is going to utilize the data? As Hassan mentioned before, that EMM data will be compared to LMD-MCD, and EMM will use GMARS to analyze and for analysis and visualization, which will be using all the three instruments of EMM. Example could be that we can correlate conditions of the lower atmosphere to the upper atmosphere. So the first tool is the LMD-MCD, which we can see it here. The link is above the slide here. We will provide all the link in the chat box. So once you enter the LMD-MCD, this is what you're gonna see, which is the interface. So what can we see here? First, at the top, we can see in the red box, we can select Mars date, which we can then select a specific season, which is solar longitude, and then we can select a specific local time that we want. And then we can see here that in the customized coordinates, where we can select a specific latitude or longitude and altitude, or all latitude, longitude that we want to look at. And then here in the red box, we can specify the variable that we want to study. We have so many variables that we can study. Examples could be temperature, pressure, density, CO column, and so on. Different mixing ratio, it really depends on you. And you can compare multiple variables with each other. And then here, the last thing we can choose is basically customizing your output that you want. You can specify the format that you want your output to be in. You can specify the color map that you want. You can specify the range value that you want. You can specify if you want it to be the output to be as a sphere or a map, and so on. So here are examples of output similar to EMM from LMD-MCD. On the left, you can see that we have water ice column at season 0, which is the season where EMM is going to reach Mars. If anyone is interested, season 0 is basically northern spring, southern autumn. The water ice column is basically similar data to EXI data. And then on the right hand here, we can see temperature, which is going to be similar to EMERS data. And then here we have a CO column, which is going to be similar to EMU's data. And the right hand, it's just a similar output, but changing the projection while using the sphere instead of a map. So the second tool is basically JMARS. So how do we access JMARS? Is basically through this link we can access JMARS, and this is the website once you enter the link. How can we download JMARS? Is basically from the blue box here, we can download it by using the specified system that you have, if you have Mac, Windows, Linux, and so on. So this is going to be the interface that you have once you download JMARS and open it. So what can we see here? And the blue box on the left, this is called the layer manager. And then the red box, which is where our data will be displayed, is called the viewing window. So in the layer manager, you basically can control the data sets that you chose. And it shows all the layers within the session that you have. And then the red box, you can you can display the data that you chose or the layers that you chose from the layer manager. So what are the similar outputs that we have from EMM? They're all under development, but here is an example, which is the EMERS layer. As we can see here, the black to white circles are basically called EMERS stamp layer, which shows a selected observation of EMERS. We can see it here in a 3D spherical projection as well on the right hand. This is just an example. So all layers of EMM instruments will be available in JMARS, but they're all under development for now. So this will conclude my presentation about the Mars visualization tools. If you have any questions, I'm open to answer them.
Thank you, Mariam. Here are just some questions that can be addressed for the attendees. Can we access LMD, MGCM, or JMARS?
Yes, you can. We'll put the links in the chat box. You can easily access them.
And when will we have access to EMM layers in JMARS?
All layers are still under development. Along the way, we will announce when we'll have the layers available. But for now, you can download JMARS and play with the layers available. So when you have EMM layers, you can easily play with them.
Thank you very much, Mariam. Just a small reminder before we proceed to the next presentation. If anyone does have any question, please feel free to leave those in the Q&A. We will either respond to you through the Q&A box or live or by the end of the session. Thank you very much. Now we can proceed to the last but not least presentation on accessing EMM science data by Imran Al-Hammadi.
Good evening, good morning, depends on where you are. I'm Imran Hamadi. I'm the Science Data Center lead for the Emirates Mars mission. Let me share my screen. Can you see the slides?
Yes.
Okay, excellent. So I'll talk today about the Science Data Center of the Emirates Mars mission, how the data flow from the Hope probe all the way to the Science Data Center until it reaches the science community. how the data going to be distributed, and what type of data will be provided to the science community. What will be available only for the EM science team, and what will be available for the science community. Then we'll see when the first data will be released to the science community and how the data release schedule looks like. We'll see also how the science team community can access the science data available at the Emirates Mars Mission Science Data Center. So the Science Data Center is responsible for receiving level 0 products from the Mission Operations Center and generate quick looks level 1 and level 2 scientific products using the softwares and the model that being provided by the instrument team facility, or what we refer to as the ITF. The SDC is also responsible for distributing the science data to the entire EMM team and the science community. We also perform our own internal SDC data management in order to maintain the secure and stable data repository for all data products that we generate at the Science Data Center, and make sure that the continuity of data provisioning is preserved. In other words, the Science Data Center should provide the data access to the science community, not only during the mission lifetime, but even after the mission decommissioning. The science products that we have at the Science Data Center should be accessible by the public.
Amran, can I just stop you right there for a second? We've had a few comments from the attendees mentioning that your voice is quite low. If you can just raise your voice for a bit, that would be great. Thank you.
Okay. What about now?
Perfect, yeah.
Okay. So this diagrams shows how the science data flows from the whole probe all the way to the Science Data Center and the science community. The whole probe, as been mentioned during our previous presentation, has 3 scientific instruments, EXI, EMUSE, and EMERS. During the spacecraft contact with the ground station, the science telemetry from each instrument is downloaded and transferred to the Mission Operations Center. That will happen through our ground network. And the Mission Operations Center will perform initial data processing and generate level 0 scientific products and other ancillary data products and deliver them to the Science Data Center. At the Science Data Center, once we receive these products, we're going to generate higher scientific products using the pipeline software that's being provided by the different ITF. So we'll generate level 1 products, level 2 products, as well as quick look products. The product generated at the Science Data Center will be immediately available to the science team of the EMM mission, and only timely scheduled will be provided to the science community, and we'll see the schedule, how the schedule looks like. So for the data distribution, all data products will be made available to the science team within the mission immediately after we generate that products at the Science Data Center. And they can access that products through the SDC website, or they can use our published API and web services that we developed internally within this SDC team. The science community will have access to level 2 and 3 products once they are released to the public based on the mission public data release schedule. We have our own schedule. Once these science products are released, this SDC platform will automatically notify the registered users on the SDC website. This diagram shows the Science Data Center release schedule for the mission. So our first release will take place approximately 4 months after the start of the science phase, and will include data from the first 3 months of observations. So after that, subsequent releases will take place every 3 months and contain 3 months worth of data subsequent to the first release. For level 3 products, we'll have a different release time. So the first release of level 3 products will take place at the same time as the second level 2 release, and will include data from the first 3 months of observations. So how the science community can access the data that being generated by the Emirates Mars mission at the Science Data Center. So we'll have two main way to access the data. The first one is through the Emirates Mars Mission Science Data Center website. The science community can go through the website, search and download scientific products and ancillary files that be used in order to generate these scientific products. They can have a look at the quick look products that we generate at the Science Data Center. There will be some visualization tools available for the science community so that they can use it in order to visualize the scientific products so that we have at the Science Data Center. We'll include some information and description about each instrument that we have at the prop. We'll include some models that been developed by the science team within the mission. Any kind of publication related to the mission will be available at the Science Data Center website. News pages will be available as well. We also developed and published some APIs and web services that can be utilized in order to retrieve the scientific products that is available at the Science Data Center. Let me show you the first version of the website. The website is still under development and not officially released. So we'll look at, let me stop share and share again. Can you see the screen now?
Yes.
Okay, excellent. So this is our current release version of the website. At the website, you can perform different things. So for example, you can search for scientific products, ancillary data as well. You can view different instrument, description about the instrument, description about different data levels. So what do we mean by level 2 products? What do we mean by level 3 products? And so on. You can have a look at some plots and visualization tools, software and models that have been developed by the science team within the project can be seen over there. We have a publication page and so on. So for the science data search, let me, for example, search for our previous data. So let's say we want to see scientific product that available at the Science Data Center for last month, October 2020. You can select what instrument you want to search for, what kind of data level you want. For the science community, we will be able only to see level 2 plus products, so level 2, level 2A, level 2B, and level 3, as well as the quick look. So if you search, so these are the current available products at the SDC. These were collected during the cruise phase. Still, we didn't reach the Mars, and These are some test data that been performed by different instruments. We have on board the whole probe. You can select any kind of products you want to download. You just click download. And the data can be downloaded to your desktop. You can also view the ancillary data that is related to whatever you select over there. So these are the ancillary data that being used in order to generate the data product, the scientific data product that we already been selected. We'll have announcement once we officially release the website to the science community. So, and it will be linked to the main Emirates Mars mission website. With that, that's all from my side.
Thank you very much, Imran. We have a question here by Mohammed Rami, which is the data going to be uploaded to planetary data archives such as PDS and PSA? And if yes, when would that be?
Okay. PDS is the central repository for NASA scientific missions. And similarly, PSA is the central repository for the ESA scientific missions. For our mission, our Emirates Science Data Center will act as the central repository for scientific missions, including the Emirates Mars mission. So any future scientific missions that will be developed and launched by UAE Space Agency, this is the central scientific products repository. So we'll have our own version of PDS, for example.
Thank you, Imran. And what does Quick Look mean and how is it beneficial?
So Quick Look is different from for each instrument. So for EXI is just the lower resolution of whatever being collected. MUs and MERS, they have a different definition of their Quick Look products that is available at the website. We'll have a specific page that describe what do we mean by Quick Look products, what do we mean by level 2 products, what kind of information, for example, available at level 3 products, and so on. So it's a kind of instrument specific.
Thank you, Imran. One additional question by Ahmed Al-Hantoubi, which is the EMM Science Data Center accessible currently, or do we need to wait for it to be released to the public later on?
So as I mentioned before, the current version is the development version. So we still didn't officially release the Science Data Center website. Currently in the development phase, and we'll have announcement when we are going to release the official website and link it to the main Emirates Mars mission website. Still, we don't have any scientific products that is useful for analysis being collected since we didn't reach Mars yet. Once we reach Mars, we start processing and generating scientific products that is useful for analyzing the Mars atmosphere. So we'll have announcement on when we are going to release the website.
Thank you very much, Imran. This concludes our session, but we have quite some time to address some questions for the presenters here. So I would like to ask a few questions to the presenters. First of all, here's a question for Mariam Shamsi. Since EMM is all about developing capabilities, what efforts the mission has put forward to develop the next generation of space expertise?
Thank you, Mose, for this question. First, do you hear me?
Yes.
Yes. So as we mentioned earlier, when it comes to Emirates Mars mission, it has a bigger purpose, and that is by developing the expertise here in the UAE to focus on space sciences, and not just in terms of science, but also in terms of engineering. So from the mission, it says it's served as a catalyst for also research institutions and universities to provide also a lot of programs related to space sciences. You can see that a lot of universities now are providing bachelor's degrees, master's degrees for students in order to encourage them and to focus on continuing their studies and to go into the space sciences fields. So the mission is inspiring for the youth to go into the STEM fields, and also it also provided opportunities for research institutions to provide these tracks for the students to continue their studies. When it comes to also developing capabilities, we're talking about being prepared also for future missions to not just Mars, but any other missions for discovering different planets. So we're building upon the knowledge that we've gained before when we talked about Earth observation. Now we're talking about Mars science, and tomorrow we might be talking about other related sciences. So it's a build on capability building, it's a build on knowledge transfer program for the UAE.
Thank you very much, Mariam. Here's a question for Mariam Youssef. Do you provide workshops on how to use LMD models in JMR software to those who are interested?
Thank you for the question. Yes, we do provide a workshop on how to use both visualization tools, which are LMD, MCD, and GEMARS visualization tool.
Thank you very much, Mariam. Here's a question for you, Hassa. What programming languages the team uses to conduct their analysis?
Thank you, Moza. So there is no constraint when it comes to using programming languages for scientific analysis. Any kind of data analysis tool can be used. The team, in fact, uses Python, IDL programming, Fortran as well, and other, and some of them even used MATLAB at some point in analyzing the data. So any programming platform that is available to analyze data can be used. There is no restriction when it comes to that. They're all helpful in reading data and doing the necessary analysis and the comparison needed.
Thank you very much, Hassa. Here's a question for you, Imran. Is there any way that the data might be available and adaptable to schools?
So as mentioned by Miriam, the main idea behind this mission is to open the data to the public and specifically the science community around the world. The data will be available to anyone who register on the website, on the Science Data Center website, whatever he's working on. So for example, from schools, universities, any kind of scientific institutions, the data is available for everyone.
Thank you, Imran. Here's a question directed to you, Hassa. We have a few students who have attended this webinar, and I would like to ask, for example, on their behalf, if I'm a research student and I wanted to be involved in doing research on Mars, where should I start?
Thank you, Moza. There are a lot of points that you can use to start and engaging in scientific research when it comes to Mars. One, you can start within your universities. There are a lot of expertise available in UAE that are currently studying Martian atmosphere. So if you found those point of contacts within your universities, reach out to them, and probably they would have projects that you can team up with and get experience and hands-on research analysis when it comes to Martian science. There are even research centers available in the country that focuses on space science, and part of that is focused on Martian science as well. There are even other platforms. As part of the Emirates Mars mission, we do have outreach programs that tries to provide research opportunities to students. One of them is the research experience for undergraduates program. So this is a summer internship for university students in their second year up to their fourth year. If they're interested, it takes place every summer. And announcements can be found within the website of the mission or the social media platforms that we have from Hamid Faraj Space Center and Hope Mars Mission. These kind of hands-on experience have been very helpful based on the years that they have been conducted with students, because during 10 weeks in the summer, students will be paired up with scientists in the field, and they would be assigned a project and a mentor. And during that period, they would be able to generate results within the topic that they are assigned. And we have even lots of students who submitted their results to scientific meetings and conferences, and it was published either by posters or even as oral presentations, and some of them even to journal publications as well, which was very inspiring. So there are a lot of points. And other platforms even that the team provides is workshops. Workshops are very regular. You can stay in tuned to our social media platforms. We do them very regularly. And during these workshops, you can find topics that can help you and aid you into analyzing Martian atmosphere data. For example, Maryam has mentioned, Maryam Youssef, that we conduct workshops on how to utilize JMARS visualization tool, how we can utilize LMD model, and these can help into the analysis process. As I mentioned, that many of our analysis would depend on comparing our own data to other spacecraft data or even other models that are existing. So these are even a different path that can be pursued to enhance the research skills students can have in the field.
Thank you for your response, Hassa. One question for Maryam Shamsi. How is the Emirates Mars mission unique compared to other missions that have been to Mars?
Yes, during my presentation, I mentioned that a lot of missions have already been to Mars and they're studying Mars in different ways, providing different scientific data. So some are studying geology of Mars and providing data about geology. Some are providing atmospheric data. So all missions should actually complement each other when it comes to scientific data. So when it comes to the Emirates Mars mission, we are going to be providing data set that hasn't been captured before in terms of different timings during the day. So if, for example, we're talking about some of the missions, they do have specific timings that they only take observation of the atmosphere. Our mission, because of our unique orbit, is going to be providing us with different times of day, studying, for example, the same atmospheric layer and providing that unique data set for different seasons along the year.
Thank you very much, Maryam. Just so I can address this for anyone who is wondering about this, for all these presentations that have been conducted today, the presentations will be available on the AMM website, and all of you will be notified once these presentations are up for you to view once again. So the presentations and the details of where you can find them will be shared with you at a later stage. Just one addition. Finally, I believe that there might be some questions in the Q&A box here. However, here's just a few questions to just specify for everyone. What would you say, Maryam, is the biggest challenge in this mission? Maryam Al-Shamsi, I mean.
The biggest challenge, as in my biggest challenge, or the mission itself?
You can specify it in both ways.
I believe the mission as a start was also challenging for all of us. It was something new for us when it comes to observing, sending an observatory or a spacecraft to study a different planet other than Earth. We usually send orbiters to study Earth and get data, scientific data for Earth. So it was challenging in terms of having this developing our capabilities again in terms of engineering, in terms of having space systems that is capable for sending a spacecraft outer Earth. When it comes to science, also developing our knowledge in terms of getting to understand Mars more, and trying to also be up to date when it comes to science community, where the research is being done in terms of atmosphere, and how we can provide our unique data set and basically contribute in terms of discovery of Mars atmosphere. So I would say these are the challenges that I think, from my perspective, are in terms of the mission.
Thank you very much, Miriam. I would say this concludes our session for today. I've shared the links for the next run of the introductory sessions that will take place on Wednesday, November 4, in the chat box. So if any one of you is interested to attend that, please feel free to register through the link provided. And again, to register for the Science in-Depth sessions, where we'll be highlighting a bit more detail into the Emirates Mars mission. The link is also shared in the chat box as well. So we'll leave it up there for you to click on these links and register, and share them as well to those who might be interested in attending the sessions as well. So I would like to say thank you for to the presenters today, and for everyone who have joined today's webinar as well. So thank you very much.